All right, everybody. Welcome to your very last data demo. How exciting is that? Man, we have done a lot this semester and we're ending out strong talking about logistic regression. Now, logistic regression, it tends to be that when we get to this stage, students like it. They think it's kind of easier to interpret and to run. And frankly, that's because you've done all the hard work leading up to it to know how to do it. All the things you learned with linear regression are going to apply here in terms of creating dummy variables and the structure of regression. But what does change is what we interpret. So with linear regression, we have the slope, right? That told us the change in y given a 1 unit increase in x. We don't get that with logistic regression. Instead, what we interpret is what is called the odd ratio. Now, hopefully you've done the readings and you understand odd ratios are not odds, but rather an expression of the relationship between two odds. Very different, right? Because you could have two groups with high odds of something happening, and the odd ratio is going to be small, and you have two groups where they both have low odds of something happening, and the odd ratio is also going to be small. So we're going to continue the theme here, looking at mental health. Now, in the reading, we looked at a regression on marital status and depression. Here, well, and in the reading, I kind of gave a little hint, right? It's like, why in the world would those 18 to 34-year-olds have such higher odd ratios of depression, right? Their odds of reporting of depression were like 3 point something times greater than those 65 plus. Why might that be? So there's a really good book that I've been reading recently called Anxious Generation. Highly recommended. And in it, the author makes a case that it has a lot to do with the internet. Go figure, right? So we are going to explore that relationship. We're going to see what impact um, time spent online has on the odds of depression while controlling for all the other things that we did in the reading. Now, with logistic regression, you know that there's a couple things that need to have happen. First, our dependent variable must be coded as a 0, 1. So in this case, we are going to be using that variable feel down. So this is how often have you felt down in the past 2 weeks? But if you read the full question wording, right, in the GSS code book, it talks about depression and a lot of other things. So this is the distribution of scores. And you know, in the reading, what we did is we took the not at all and turned that into a 0, and several days, more than half days, nearly every day, and turned that into the 1. Now, if you want, you are more than welcome to use the syntax link that was in the reading to kind of get a head start. And this is what it would look like. So here is the syntax I'm using to create that dependent variable for depression. So feel down is 1, which means it was never. I want that to be the 0 and all the other feels to be the 1. With logistic regression, it has to be binary, right? And it has to always be coded as a 0, 1. It can't be 1, 2, or anything like that. It has to be 0, 1. And you want the 1 to represent the thing we're interested in knowing more about. So I'm interested in knowing more about the feelings of depression. So I want that to be the 1. If I was interested in the opposite, let's say I want to do a study predicting odds of not being depressed, which might be useful, right? You could look at, I guess, design a study where you have that as your dependent variable. Depends on the kind of study it would be. But in this case, we're going to do this. All right. So again, you have access to the syntax to kind of get you started. I'm going to go ahead and run all of this syntax. And yay, no errors. Be sad if there was an error right here. Okay. All righty. Now, the next step, we need our internet variable, right? And internet use in the GSS is a little rough. They don't even have a question on here on like social media. If they do have a question on do you use the internet on your phone, but it's just like straight up that yes, no, do you use internet on your phone? In fact, the question where it says like BlackBerry and stuff, so it shows how dated it is. So what we're going to do here, we're going to just evaluate what we got. So let's run a frequency on this variable here, www.hr. So this is asking the respondent how many hours per week they spend online, not including, let me see, let's find the exact question wording. So this is what it is. So not counting email, how many minutes or hours per week do you use the web? Include time you spend visiting regular websites and time spent using interactive internet services like chat rooms, Usenet groups. That's even like before my time, bulletin boards and the like. Yeesh, that question so needs to be updated. See, these are all the questions that are available in the 2022. So it's like, do you use a computer? How many minutes do you spend on email? Uh, do you use internet through your mobile device like a PDA or BlackBerry? Anyway, limitations, but we're going to keep going with this www.hr. So what do we do? This is quite a list of data here. And if you remember in the reading, I say that continuous or numerical data in logistic regression is hard to interpret, right? Because it's not that the odd ratios show risk, they just show the difference between the odds of two groups. So when you have continuous data, it gets really tricky because it's like the change in the odd ratio for each increase in the number of hours. So when we have continuous or numerical data, I highly recommend collapsing it down. So how can we do this? Well, it depends on the type of variable and what you're looking at. Sometimes it would make sense to say like, okay, I'm just going to keep the zero to zero. But that doesn't seem like we can do that here. We only have 7.8% who said 0 hours. And I don't know. I think there'd be more of a dose response, right? That as frequency of internet use goes up, I would suspect, this is the hypothesis, that the odds of depression also go up. So one thing we can do, I think this is what we're going to do here, is we're going to use quartiles. So we're simply going to recode our data so that we are capturing internet use by quartile. Now we can look here at our frequency list. I'm gonna have my little notepad ready to write. Oh, you can't see it. Oh, there we go. I have my little notepad ready to write down what the quartiles are. We could do it that way. We could also, if you recall, we can come here to explore. Throw in www hours. Oh, that's minutes. Don't want that one. Let's put in hours. And in statistics, we can tell it to give us percentiles, right? Along with descriptives, why not? We'll continue, then okay. So the nice thing here is it did all of that cognitive work for us. It tells us what our quartiles are. So first quartile, 0 to 3. Okay, so I'm going to write that down. So 0 to 3. And then it would be, or I'm going to say less than 3, right? And then 3 to 8 is the next quartile. And then 8 to 20, and then 20 plus. And the way we're going to code it, we're going to do like right up to it. So it'd be like 7.99 or whatever. So let's create a cleaned up version here of our time spent online. Now I could do it in syntax. I'm not going to. I'm lazy. I'm feeling lazy today, so I'm going to do it in transform. So I'm going to come here to transform, recode into different variable. Let's get that www.hr, make sure it's the hours. And I'm going to call it www Sounds like I'm saying some wrestling thing. HR underscore four. I don't know, quartiles, right? And then old and new values. So how was it coded? Were they whole numbers? I want to look at the output just real quick. Yeah, they're whole numbers. Okay. So we're gonna actually go right to see 3 is 28.6. So we're gonna go to 2 actually. Okay, so old new values, range 0 to 2. That's gonna be our first quartile. And then 3 through 7, that's gonna be our second quartile. 8 through 20 is our third. And 20 through, I think it was 168, is going to be our fourth quartile. Okay. Oops. Can't do that. 8 through 19. Oops. Sorry. There we go. 0 through 2, 3 through 7, 8 through 19, 20 through 168. Click continue. And okay, I'm going to hit paste just because I want to save this syntax for later. Let's run it. And now let's add our labels here real quick. Actually, I don't want. Yeah, okay, fine, we'll do it. I just heard someone being like, "No, you should always add your labels, Brother Burger," and it's true. Although whoever that was, that's not how you talk. I apologize. All right, come on, dang thing. There we go. Okay, so value 1, this is our 0 to 2 hours. 2, 3 through 7 hours, right? Yes. And then 3, this is our 8 to 19 hours. And then 4, 20 plus hours. Now, I probably should have done that in my syntax, but it's okay. Let's run a frequency just real quick. I want to just check how they got binned compared to the original. And yeah, it looks pretty quartile-ish. Maybe the 8 to 19. Did we screw that up? Not you. Did I screw that up? 18. See, it's like right in between, you know? So I think I'm okay with that. All right. So we have a cleaned up version of our variable. Gonna add the value labels. Do it twice. www.hr underscore 4. 1 is 0 to 3 hours. 2 is 3 to 8 hours. 4 is 8 to 20 hours. And that's 3. And then 4 is 20 plus hours. Sweet. And then execute. All right. So we have our variable, but now we need to do the next part, right? We need to create our dummies. So this is our dummies for www.hr underscore 4. All right. So dummy variables, we're getting pretty good at that, right? The 1 represents the one group and 0 is everyone else. So I'm going to create compute. How do we want to name our dummies? Remember, you can't start with numbers, so we can't be like compute 0 to 3, right? Maybe what we'll do, I'm going to say, let's see, I'm going to go like Q1. No, don't do Q1, right? What would be a good way to do it? Maybe just hours underscore 03. I guess you could say 0 to 3. Hours 0 to 3. That's okay. And you know what? Since we have it kind of phrased that way, I'm not going to do like a underscore D. That just seems like to complicate it. Okay, so compute hours 0 to 3. That won't be too bad because then when we make the next dummies, it'll be easy. We just have to change the numbers. I like that. Okay, execute. Now, if www.hr underscore 4, because we want to use a nice clean version of our variable, right? Can you imagine making the dummies with the original www.hr? It'd have to be like, if values are greater or less than this to this, then it's that. I mean, it's doable, but the nice thing here with this and why I recommend doing this, when you do your descriptive table, right? You are going to want this variable this way so that you can report on it. Okay, so www.hr underscore 4 equals 1. Hours underscore 0 to 3 equals 1. Now I'm going to be lazy and I'm going to use the does not equal sign here. So if it doesn't equal 1, hours 0 to 3 equals 0. Now we can only use that does not equal if we have a nice cleaned version of the variable. If you have like a -99 or other missing values, it will suck those in. It won't suck in system missing, right? Because it's like those values don't exist or those cases don't exist. So we're okay here where we've created a clean version of the variable. Then execute. Now we just have to do this 4 more times. 1, 2, 3. There we go. Okay, so let's change this to a 3, this to an 8, this to a 3, this to an 8. That's not too bad. 3, 8. Yeah, don't forget to change. That's the danger of doing copy and paste, right? As some of you have found, it's easy to screw it up. Okay, now I changed that to 2, right? Because 2 represents the 3 to 8 group, and then does not equal 2 captures everyone else. Okay, now the 8 to 20. 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 And then this changes to a 3. And now 20 plus. Okay, so you can't do a plus sign. So I'm just going to say hours 20. And I'm just going to have to kind of remember. Hours 20. 20. Yeah, you can't do special characters, right, in variable names. Okay, and then we'll change this to the 4. And this should be our dummies. Now, I notice some of you have been putting value labels and variable labels with your dummies. You can if you want, right? That's totally fine. But sometimes it will kind of mess up how the output shows up, right? It'll put in the labels, and sometimes that makes it harder to understand what's happening. So you're fine not putting value labels. You're fine not putting in variable labels here. Okay, so we'll run this. Let's check our output, make sure we're looking good. Okay, no errors, and you always check your dummies, right? So I'm going to run a frequency on my new variable, www.hr4. Oh, you know what? Before doing that, I want to run the syntax on it because I want to get the label. Well, I guess I do have the labels because I put them in manually. Made you do that twice. Builds character. All right. So we got WWWHR4, and now let's throw in all of our dummies, our new dummies here, and then click OK. And what we're looking for is to make sure they all match up, right? And we got 0 4s or 0 1s across them all. It's helpful sometimes looking up here at the statistics box where you see the valid and the missing for all the variables. Like with the dummies, that should all be the same, right? Because it's coming from this same variable. Okay, so in WWWHR4, I had 598 people that said 0 to 2, and oh, I called it 0 to 3. Son of a gun. Oh, and 3 to 8, 8 to 20. Oh, someone is upset right now. So am I. Let's fix our stupid syntax. And see, it's like, do I redo the video up to this point just because of that? No way. Sorry. All right, so it's actually 0 to 2. Son of a gun. But this is the nice thing about having your syntax, right? It's like it's super easy to fix. So this would be 3 to 7, 8. And this would be 8 to 19, not 20. Fallibility, brother burger. Okay, and then 20 plus. Now, what's going to be awkward? We're going to have a bunch of those variables. So I'm going to go ahead and delete those old ones. There we go. 0 to 2, 3 to 7, 3 to 8. And then did I not grab? Oh, but because that one already existed, the 20 plus, I just deleted it. Oops. Luckily for us, we have our syntax. Okay. There we go. I'm going to close out my output so I get a nice clean output. Now let's check our variables. Oh, son of a gun. Oh, I think it's because those variables no longer exist. So we'll put in our new ones. There we go. And now we are going to be checking, right, to make sure they match. So 0 to 2 is 598, and that's what it shows up on our 0 to 2 dummy, 598, right? That one matches there. 652 matches, 587 matches, and 779 matches. Cool. Now, before we run our regression, let's run just a crosstab here real quick. We probably should have done that a little earlier. I know you're excited to run the regression. So am I. But remember, when we get our regression results, we get those odd ratios. And the odd ratios don't really tell us a lot about risk. So it's good to understand what the general relationship is between our variables before going into the regression. So I'm going to find here my WWWHR4, put that into the column because that's the independent variable. And I'm going to put fill down in the row. Okay. Let's do this. Click continue. Okay. So we have unweighted there. Let's turn our weights on. Sorry about resizing the screens all the time. Okay, so we're going to turn our weight on. So make sure it's the one that says it's a copy of WTS NRPS. Okay, survey weight. And let's rerun that crosstab. So let's see what we get. So here's the unweighted. And I'm kind of looking in here to make sure our counts look okay. We have enough people in each cell, and we're looking good there. Okay, let's look here though. Fascinating. Guess what? It's not showing up as being statistically significant. Isn't that interesting? So here, I mean, it's approaching significance. And we can kind of see there's this like U-shaped relationship, 35.7 in the 0 to 2, then 30, 29.8, and 36.3. Okay. Now, what is the benefit of running this in a regression now? Is it possible that there are other socio-demographic characteristics that may influence internet use and frequency of internet use? Now, the cool thing is we're going to be able to control for those, and we'll see if this like non-relationship still exists, because that doesn't seem to make sense given everything we know. It seems like that if you spend more time online, that should probably increase, right? Those odds of filling down, the probabilities of filling down. So let's see what happens when we run the regression. I actually don't know. This is the first time I'm doing it too. Okay, so we're going to go to Analyze, Regression, Binary Logistic, not linear, binary logistic. Okay, so our dependent variable, that is this field down variable. And we're actually going to approach this using a nested model approach. So with nested models, we start out with a few variables at a time and we expand the model. The benefit of doing a nested model is we can see what impact including additional variables has on the controls or independent variables that we had previously. And sometimes you can find some really interesting things. There's differences and changes between the variables. Okay, so we have fill down D. Now let's just run the model with internet use, since that's kind of our main independent variable. Since my hypothesis, my theory is that as internet use goes up, feelings of depression will also go up. I'm going to leave 0 to 2 as the reference. So I will not include them, right? Right? Okay, so they become the reference group. So 3 to 7, 8 to 19, and then 20. Make sure to turn on, click options there and turn on your confidence interval for the exponential B, which is the odd ratio. Exponential B, odd ratio. Keep that, like ingrain that in your head. And then my weights are on, then click OK. Now, the coolest thing about logistic regression, we only have to run it once because, son of a gun, I forgot to do something. It gives us the unweighted ends. Okay, but notice here, I forgot to do something. See down here how you have like this parenthesis 1 thing? Okay, so what PSBP is trying to do is trying to be a pal. But it's like that friend who has good intentions, but just messes things up. So it's trying to help you create dummy reference groups because it knows that the variable is nominal. Look up here real quick. See this categorical variable coding? This shows why this is screwing it up. So PSBP is taking the first value and making it the test value and the second value and making it the reference, which makes sense given that a lot of times in surveys with binary data where it's yes, no, how is it usually coded? 1 is usually yes and 2 is no. And usually we're more interested in the yes thing, right? And its influence on our dependent variable than the no. So see here, this is how our variable's coded, and then this is how it's treating it in the regression. But who's the 0 now? It's the 1. So it flipped it on us. So if you ever come across findings that are the opposite of what you expect, check your coding. So we got to fix this. So to fix it, you have to come down here to variable view, measure, and see how it's all nominal. PSBP. It used to not do this. You have to change all these to scale, which is so annoying. I mean, even the one that is a dummy, who cares? It's not going to change anything. Now I'm going to go ahead and change all of these to scale because we're going to be using all of these dummies to help us understand that relationship between internet use and depression. Yeah, it used to not do this. This was just in the last one or two updates. We're almost there. There we go. Okay. Let's close out our output. Good, I did. And let's rerun that regression now. Although I guess that's good for you to see, right? Just in case, because it is a common thing that happens to students. Okay, so here we have our regression stuff. Let's just kind of walk through a couple different things here, starting at the top with dependent variable encoding. I always like to look at this. Like I say in the reading, it's good to make sure that PSPP is treating your dependent variable the way you intend, where the 0 is 0 and the 1 is 1. If this is flipped or those don't match, you need to re-evaluate that, right? Because this is showing that we are predicting the odds of feeling depressed. Unweighted cases, bless its heart, right? We don't have to run it twice. We have 1,563 cases. Before coming to the model summary, let's look down here, variables in equation. Okay, don't interpret the B. That is the log odds. Now you can use the log odds in this really complicated formula to do specific probabilities. You will like never use that. What we do use is the exponential B, and that is the odd ratio. Now, before we get all excited and try to interpret the odd ratio, and even before looking at the significance levels, which you can tell they're not significant, look at the confidence intervals. So it ranges from 0.56 to 1.1. Now, odd ratios, they can range for anywhere from like almost 0 or 0 to, and I think it can't be 0. Yeah, it can't be a complete 0, to infinity. So you can never have a negative odd ratio, which makes sense because these are ratios. So if someone had a 1-to-1 odd ratio, that means that both parties have the same chance or equal odds, right? There's no difference in their odds. Now, since the confidence interval goes from below 1 to above 1, that means there is a possibility that it is 1. So if an odd ratio is 1 to 1, and this is, in comparison to our reference group, which is the people who use the internet 0 to 2 hours, then that means there is no difference in the odds between them. So even if like you never were able to see the significance values, you could tell if an odd ratio is significant. I mean, sometimes there'll be just a tiny little bit overlap and it'll still show up as significant. But generally speaking, you can tell if it's significant or not by looking at the odd ratio. And look at our Daggle-Kirky R-squared, 0.01. We are doing a very bad job here of explaining depression. It does not seem this variable is doing much in helping us understand it. But now let's include some other variables. Let's control for some other things. Since we're doing that nested model approach, right? So when doing nested models, you tend to go from, well, I would like you to go from your first model where it's just the independent variable, and then you tend to do like demographics next, right? So you're controlling for those things like age, race, and sex. So let's go ahead and do that. So I'm going to come back here to regression, binary logistic. I'm going to leave those variables in because it's growing on itself. And let's control for age, race, and sex. Now that 18 to 34 group, right? That seems to be the group we're interested in. So I'm going to make 65 plus my reference. So I'm going to put 35 to 64 in first and then 18 to 34. I know also the research tends to show that social media, internet use has a more negative impact, it has a negative impact on females more so than males. So I'm going to put male, I'm going to leave male as my reference. I'm going to put female in. And then with race, it's always tricky, right? It's like, do you want to focus on the experience of minorities or the group that has the highest rates of depression to begin with? And that it does tend to be whites. So I'm going to keep going with like what we did in the reading, and I'm going to put in black and white and leave Hispanic as my reference. Okay. Wow, this is a lot of stuff here now. Let's click OK and see what happens. Right. Okay. So this is kind of my process of what I would do. First, I'm going to look at the included in the analysis. 1325. So we dropped a bit. We lost some cases, and that's probably because our race group is only including white, black, and Hispanic. We're not including the other category. So right there, we have a big drop. Okay, let's look at a few other things. Let's look at like the odd ratios here. So as you can see, the internet use one still is not pinging, right? This 8 to 19 hours is almost significant. I mean, it's at the 0.1, right? And this 0.71, we would interpret that as um, the odds of depression for those that use the internet 8 to 19 hours was, let's see, what would be that difference? I just had it 29% lower than those that use the internet 0 to 2 hours than their odds. Look at the impact on age, though. Remember in the previous one how that was a way higher? So it does seem that internet use is helping to explain some of that impact of being 18 to 34. Not all of it, right? It's still there, but it's helping to explain some of it. In fact, I want to know now. Let's see. PDF danger, because it may be different from what you see. Okay, so when we look at that age group, yeah, see here, it was 3.11 and 3.14. And then here, where are we? 2.18. So it did. Internet use helped explain some of that effect. Interesting. Okay, now let's include social class and let's do marital status too, since we have it, right? All right. So we'll come back here to regression, binary logistic, and let's find us. Let's put in the marital one first. Okay. So who should we leave as the reference? Let's leave not married as the reference. So let's put in cohab and married, kind of like what we did in the previous one. And then class, let's leave lower class as the reference and put in working, middle, upper. Because then we can see like the change as class goes up. I guess we could have gone the other way too. In fact, let's do that. Let's go the other way. You're like, but Brother Burger, we're watching the video and trying to follow along. I know. I'm sorry. But let's leave upper as the reference this time. So just because I'm thinking about how my table's going to go, where upper will be the reference. So I'm going to put middle, working, and lower in. And then click OK. Right. Let's see what we get. First off, our Nagel Kirky, it went up. Yay! It went from a 0.05 to a 0.11. Not the best. So Nagel Kirky R squares always tend to be a little lower in social sciences. Again, just because our world is incredibly complex, it's so hard for us to fully encapsulate the human experience in a few variables in the model. Don't think that this is what this is doing. Think of this more as like a surgical like examination on different factors. Like, yes, we need to fully recommend that these factors are not the end all of what predicts the odds of depression, but they can help us a little bit better understand the phenomenon, right? We can see that this is having some kind of impact. Okay, so the internet, no impact. That is so shocking to me. I thought for sure it would show up. That's why I chose it. But I guess that's good. That's science, right? Like it's not a thing. Okay. Now, that could be because of some limitations of our question. Um, Hours spent online is very different than trying to understand like how that time is spent. I wish we had a social media use question on here, right? Because I think that is the thing that probably predicts the relationship between internet use and poor mental health. It isn't necessarily internet use, but social media use. All right, looking at age, wow, look how different that odd ratio is, though, for the 18 to 34-year-olds compared to what we saw in the help document. So even though the internet use stuff isn't significant, it still is helping to explain some of that impact. Okay, let's see what else we get. So race is, oh, you know what we forgot to put in? Oh, no, we did. We got female in there. Okay. So being female increases the odd ratio. So females' odds of reporting being depressed were 30% greater, right? Because we can take 1 minus or 1.3 minus 1. 30% greater than males, than the odds of males when controlling for everything else. No impact by race. The cohabitation thing doesn't matter. Wow, look at that. Being married still has that positive impact on lowering odds of depression compared to those that aren't married. Um, Middle and working, look at that. Those aren't significant because now our reference is upper, right? But being lower class, yeah, look at that. Increases odds of depression by 2.39 times compared to upper class when controlling for everything in the model. Okay, well, this is pretty cool stuff. We got some fun things here. And we have our regressions. We only had to run them once because of the fact that it gives us our unweighted ends. Ah, right. Think we can make a table fast? Let's make a table fast. So I'm going to export this. So this is depression and um, internet use. Okay. I'm like looking here, make sure there's nothing in my. Oh yeah, look, there's the Ward Youth Council agenda. So nothing too crazy in there. All right, agendas. I am good at making documents. I would have been a really good bureaucrat. Okay, let's open up that Excel file now. Okay, depression, internet use. This is how we get our information in Excel after doing that. Okay, so we sometimes it will screw these up, but it looks like they're pretty good. So we have our odd ratios and we have our confidence intervals. Now I am totally going to cheat and I'm going to use the logistic regression table from the help document. And I would totally recommend you do the same kind of thing. Okay, where is it? There it is. So I'm going to come in here. Come down, find that table, copy it, open a new document, paste it. There we go. Okay, now I just need to kind of fix it up to my research question. I'm going to delete some of this stuff just so I don't get confused. I forgot the ones there. Dang it. Alrighty. So I still have 3 models, but I don't have marital status at the beginning. It's internet use. Okay, now I have 4 categories, so I'm going to drop that. 0 to 2 hours, 3 to 7 hours. Ooh, we do need to put like per week, right? And then 8 to 19 hours, and then 20, 20 plus hours. Okay, now in here, let's look at our final model because that's going to tell us how to order stuff. Okay, so next we have age, and that's set. Then we have sex, and then we have race. And then we need to add in marital status. Oh, I should have like copied and pasted, huh? Oh, well. So I'm going to add in some rows below here. Marital status. 1, 2, 3, 4, 5. Not married. No cohab. I'm just going to say not married. I think that's kind of assumed. And then what was the next category we had? Cohab. Cohabitating. It's one of those words I struggle spelling. And married. Okay, now our class is a little different, right? Upper class was our reference. And then we had middle class, working class, and lower class. Okay. Now I'm gonna have to pause the video because I am late, or not late, but I'm going to be late to an appointment to donate blood. So I'm gonna pause the video, and when I come back, um, we're going to finish filling in this table, okay? All right, so we're gonna stop the video for now, and then we'll kind of move on. Um, but maybe real quick, what I'll do, let's add our ones, because that's like our reference groups. So we know that male is our reference, Hispanic is our reference, not married is our reference, and then upper class is our reference. You know what? I bet. Can I do this in like 5 minutes? No. Okay. So we'll come back and then I'll show you how to fill in that table.
1 hour later.
All right, everyone. I'm back. See, I donated blood. So let's go through how to get the information from our output to the table. So I already have here my regression results in an Excel file. And you can see the different columns, right? So the ones that we're most interested in, probably just these 3 here, right? Where we get our significance levels, our exponential Bs, which are odd ratios, and then the confidence intervals for those odd ratios. And just to review, we should have our table here looking good. Now this is odds of depression and I'm going to say internet use, demographics. You know what? I'm going to be a little lazy. Just say and socio-demographic characteristics. Socio-demographic. There we go. I don't like that characteristics. Okay, there we go. So let's get the information in here. Now in model 1, we just have internet use, right? So we just need the odd ratios and the confidence intervals for that model. So we have it here. We have our odd ratios, which is really nice because we can literally just copy and paste these over into here now. Boom. How nice is that? Now, the confidence intervals. So with linear regression, it's good to use a comma in between your lower and upper. With logistic regression, we can use a hyphen because we don't have negative odd ratios. You can't have a negative odd ratios. So what I'm going to do here, though, to make my life easier, instead of like copying or typing in, because we want all in one cell, I'm going to use a special function in Excel. So I'm going to say equals and then use the and sign, quote, a hyphen, a quote again, and an and sign. Oops. Well, first, I'm going to click on the cell and then the and sign, quote, hyphen, quote, and then the other cell. What this does is it will combine the information from both cells, and whatever is in the quote, in between the quotes, will show up like in between. So check it out. There's my confidence intervals in a nice range for me. And I can just kind of drag that down. There they are. So I can copy these and paste them right there. Isn't that slick? Okay, let's do the same now for model 2. So I'm going to copy my you just can't copy them all, Brother Burger. So we're going to copy the odd ratios for internet use, paste those. Then I'm going to copy the ones for age. Make sure they're in the right spots, right? 18, 34, 18, 35, 30. Yeah, okay. And then for female, I'm going to copy that one, paste it, write out that extra space. And then black, white, paste those. And then for the confidence intervals, I can come back up to where I had the formula here. I can copy it, and it's not going to copy the numbers, but it's going to copy the formula. There's my confidence intervals. So we'll copy the ones for internet use and paste. The one for age, oops. Paste. Female. Paste, take out that space. And then black, white. Paste those. Okay, now let's do model 3, our biggest one. Got to copy that formula again. There we go. Okay, so let's get the odd ratios. Oh, wow, look at that. The hour 21 is 1. Isn't that fascinating? And then age, female. Oh, and I'm using Alt Tab to kind of switch between windows. If you haven't used Alt Tab before, it will change your life. Paste. Then married cohab. And our, oh, see here, they're like backwards, right? So I need to copy upper. Oh, shoot. My first model, or the last model here, I still had lower as the reference. That stinks. Because I wanted to make upper the reference. And it looks like in my other ones, oh, I have it twice there. That's right. We ran it once. Oh, no. We ran it once and then we ran it again. Does that mean I need to redo it all? Yes, it does. Or no, we're okay. So the only thing we need to change, and that makes sense, right, is, let's just double check, 0.83, 0.57. Yep, okay, there's the social class, where upper is the reference. So it goes upper, middle, working lower. So we'll grab those exponential B's and paste those. Oops. And let's take the confidence intervals. Let's do it on the regression we want down here. Okay, so time online. There's our confidence intervals. Age, female. I'll fix that. Sec, black, white. Married or cohabit married. Oh, did I have that backwards? No, cohab married. And then upper class or the classes with upper as the reference. Very cool. All right, let's fix up a few things here. One thing as you're making your tables, make sure there's the same number of decimals across decimal places. So see like here where it only goes out to one decimal. Um, let's fix that. So we're going to add some decimals here, like this one too, this one here. You just want to make sure they're consistent across. Okay. This one, and down here. There we go. Okay, we're almost done. We still need to put in our significance levels and then the valid ends and the Albuquerques. Okay, so the stars. Yeah, the stars, right? It's kind of a pain sometimes to like figure it out. So I want to show you a trick. I like this trick. So we have our sig values here. I guess, but we won't start with model one since none of it's significant. But let's start down here with model two, okay? Now in Excel, you can use this really cool conditional formatting option. So if you click that, you can come down here to highlight cell rules, and then you can tell it to highlight cells a certain color. So if it's less than 0.05, I want to make it, let's see, how do I like to do this? I think green, okay? But then you can add rules on. And then I want, if it's less than 0.01, I want it to be yellow. And then if it's less than 0.001, let's make it red. Now watch this. I'm going to copy, but not the cell. I'm going to highlight, paste special, and then formatting, and then check it out. It highlights the ones that are significant and tells me the number of stars they should be, right? Because I know yellow is 0.01, so 2 stars. Okay, let's go down to our correct model 3. Let's do the same thing there. So I'll highlight the sig values, paste formatting, and there I know which ones are significant. Okay, so in model 2, I need to give these 2 stars. No, not the age 35. Sorry, it's female in 1834. It's going to say, see, when I went to go give the stars to this 1.06, I automatically knew something was up because the confidence interval goes from 0.64 to a 1.75. Okay, so 2 stars here. and 2 stars here. And then in the last model, okay, so age 1834 and female, they get 1 star. Forgot our 0 there. And then married gets 3 stars. And lower gets 1 star. All right. We got our significant levels in. Now let's do our valid ends and the Nagelkerkeys. So let's start with model 1. Okay, so model 1, we're going to look for the included, right, in analysis, the unweighted n. So we have 1,563. 563. And our Nagelkerke, 0.01. Boo. Okay. Now, let's go to our model 2. So here our included analysis is 1,325. It's making a different font size or different font types. That bugs me. And our Nagelkerke is 0.05. Then model 3, let's go down to the correct one. 1,312. And our Nagelkerke, 0.11. Sweet. There we go. That's a pretty good looking table. I like it. Now it is weird that there's different like font types. So let's change everything to Helvetica. That's one of my favorites, but you can do whatever you want. Usually with tables and figures, you want to do something sans serif. So you don't want to use Times New Roman or anything like that. I think we're looking good. It's a fine looking table. Now let's just look here at a few things. That's kind of interesting. So first off, I am really fascinated that internet use didn't matter. I really wonder though if it has more to do with like how the internet is being used, and maybe it really shows the limitations of this question. But it's fascinating, right? That it didn't ping at all on feeling depressed in the last 2 weeks. Age still mattered, right? But it was very different than what we saw in the write up or in the reading. And look here, it goes from 2.18 to 1.76. It looks like including marital status and social class helped explain some of that effect of being 18 to 34. Not all of it, right? But it did kind of lower it. Being female, it didn't seem like it really changed a whole lot. I mean, it goes from 1.4. Let's do that. Sorry, I'm like doing stuff on the side. It bugged me that the spacings weren't right. Um, Being married seems to reduce it a bit, but not all the way. Isn't that fascinating? And then here with race, no effect. Marital status, being married is probably like one of the strongest things here that like lowers it. And then being lower class increases it. All right, everyone. So good job. That is logistic regression. And it'll be good to continue working on this with you in class and the assignment. So have a fantastic day, and I will see you soon.